Okay, we're going to look at igneous rocks. So we're leaving minerals behind. Well, we're not. We're still going to use minerals. But remember, minerals are just made of one type of chemical composition. And the whole structure is the same chemical composition. A rock, by definition, is multiple minerals. So it has multiple different chemical compositions within it. And sometimes that's really easy to see and sometimes it's not. So we're going to start with igneous rocks. And igneous rocks are, let's see if I can make this a little larger, are naturally occurring solids combination of minerals. Igneous rocks form deep underground from magma. So basically, they start from being melted. And we identify igneous rocks by their texture, and each texture has a different name. If you have large crystals, it's one thing. If you have small crystals, it's aphanitic. So all minerals crystals are really hard to see. This is an aphanitic rock. Good things to write down in notes. I don't usually make you take notes, but if you use notes, you can use them on the test. So an aphanitic rock, that is, it cooled so quickly that only small crystals had time to form, and this cooling time is going to be hours to months. This is not like decades to cool. Whereas a phaneritic rock, igneous rock, has big crystals. And this means the cooling happens slow enough to allow these big crystals to form. We're talking cooling time of years to thousands of years, depending on how big the crystals are. And this is only going to occur deep underground where there's still enough heat to keep it melted for thousands of years, but cool enough to allow crystals to start to grow. So aphanitic, small crystals, alphabetically comes first. Phaneritic, big crystals, bigger crystals, comes later in the alphabet, if that helps you. And porphyritic is a combination of those two. It had two different cooling times. It had long drawn out cooling times, like we set up here, from basically a year to thousands of years to start getting those bigger crystals here that we can see. But then something happened. We had uplifting. Something accelerated that cooling where it was allowed to cool faster. So maybe we had uplifting, an earthquake or something happened, or a magma eruption occurred, kind of adjusting the structure underneath, forcing some uplifting to occur. But anyway, the rest of the crystals now formed much more quickly, much closer to the surface. So porphyritic is a combination of aphanitic and phaneritic. In other words, it's got the big crystals and it's got the little crystals. Two different cooling times. The next two we're going to talk about are instantaneous cooling, and one ends up being glass and one ends up being something you scrape your feet with. So, by the way, do not scrape your feet with obsidian because it's glass and it would cut you, so don't confuse the two. So, glassy is cooled instantaneously. It's either magma thrown into the air and instantly cools, or it's extruded underwater and it comes in contact and instantly cools. There is no time for any crystals to form, and we end up with glass. So this is actually called obsidian. And snowflake obsidian is simply really old volcanic glass that is starting to kind of think of it as rotting away. It's chemically changing a little bit, and then you get this kind of white flakes that happen on it. Vesicular is basically a volcano with a gas problem. So vesicular texture is found in extrusive, aphanitic, or glassy igneous rock, which is a fancy way for saying the stuff is shot out of the volcano. And because when you're deep underground, there's so much pressure, it keeps the gases from the magma dissolved. And as they are released, think of like you shake a can of pop and then pop it open, it's going to basically explode out, right? Well, that's the same thing that happened here. In this case, magma is released from pressure, so all the gases that were dissolved into it explode out, creating these holes within the magma itself, and you get this vesicular igneous rock. And it's a cooling time of instantaneous. Again, ejected underwater, ejected into the air. That release of pressure, that decreasing in pressure, allows the gases to come out of solution, creating these pockets. And we call this pumice, and pumice stones are used to scrape dead skin from the bottom of feet. So don't confuse the two. Pumice good for feet, glass bad. All right, so now if we take all of those descriptions, we actually can take that texture and a description of the rock we're looking at and figure out its name. So if it's phaneritic, there's two different distinctions here. So remember, phaneritic is the big crystals. If it's multicolored, we call it granite. If it's black and big crystals, so we call it gabbro. So phaneritic rocks can be defined into two categories for our purposes, granite and gabbro. Aphanitic, those small crystals, if it's black, gray, or dark green, we call it basalt. Vesicular, that is full of gas, the volcano with a gas problem, that's our pumice. And glassy, no crystals, instantaneous cooling, that's obsidian. This chart would be great to see on the test. In fact, if I were you, I would make sure you copy down a chart like this so that you can use it on the test. And so this is, I'm giving you some information. In this case, I told you the second phaneritic, that's big crystals and black in color. Remember, that's gabbro. But my recommendation is, for this assignment, the set of notes, I'm giving you like unlimited attempts. It keeps the highest score. But you should practice this right before the test. In fact, you should practice this as soon as you take it. Now, you should get it right on the first time because the answers are right here. My suggestion is try this on your own, test yourself, but before you submit, make sure you have it right. That way you ensure you have a good score. Then after that, just keep practicing until you can do it without looking. That's my suggestion for how to do this assignment. As always, if you need help, ask questions.